Hey dosers, what's up? Welcome back to another video. Today we are going to be going through 24th October 2024, the paper 1 past paper, and this is the time Z1, time zone 1. So let's get right into today's paper, and this is a paper 1, so it's non-calc, so please do not use your calculators. So points A and B lie on a circle with center O and radius r centimeters, where AOB is 1.5 radians. This is shown in the following diagram. The area of sector OAB is 48 centimeters squared. So I want you to pause the video and have an attempt at it before I start explaining, and I want you to remember that this diagram is not to scale. Okay, hopefully you've attempted it. If not, pause the video and try again. So we know that the area of a sector is 1/2 r squared theta. Yes, and this is equal to 48 centimeters square. This is the area of a sector, is what they've given us. So we know this is the formula of area of a sector in terms of radians. So now we have to attempt to solve for r squared, because they have given us r theta, which is AOB. This part over here is 1.5, so theta is equal to 1.5. We are trying to find out what r is. R is question mark right now. So if we plug in 1/2 r squared times by 1.5 is equal to 4.8 centimeters squared. So you obviously multiply 4.8. Sorry, this is 48. Why did I write 48? 4.8. This is 48. Sorry about that. 48 centimeters squared. So you multiply that by 2, you should get 96. And then you divide by 1.5. So r squared is equal to 96 over 1.5, which should be 64. 64. Yes. Yes, 64. Okay, and then you square root r. You do the square root on both sides. So you square root this, and you square root that. You get r is equal to plus or minus 8, and you know r, since it's a distance, r can never be negative. You can't have a negative radius, so it's just equal to 8 centimeters. So that's A done now. Now B, they've asked us. In B, they have asked us find the perimeter of sector OAB. So we know this right here is 8 centimeters. And this right here is 8 centimeters, but we don't know what this is. We have to find out what BA is. We have to find that length. So we know the length of a sector is just the perimeter of the overall perimeter. So P is equal to 2r plus r theta, because this is how you find the length of BA, r times theta. So you take 16 because it's 8 times 2. 8 times 2, our radius is 8. So 8 times 2 plus 8 times theta. Theta is 1.5. So we just plug that in. Since theta is equal to 1.5, you get our final answer as 28 centimeters. Yeah, that's the perimeter. Let's move on. Question number 2, and this one is based on probability. So two events A and B are such that P of A is equal to 0.65, the probability of A is 0.65, the probability of B is 0.45, and the probability of A union B is 0.85. So first what I would do over here is I draw a Venn diagram, because they're obviously talking about A, they're talking about B. Now they've said that this is A, this is B. They said P, probability of A union B, that means the probability of both of these combined is 0.85. So that means the outside must be 0.15. Because in the end, everything added up in this circle has to be equal to 1. Everything has to be equal to 1. Right? So if P union A, this entire part, is 0.85, that must mean that the outside is 0.15. Now they said P union A is 0.85, and PA and PB are the values are both given over there. So to find, you have to find over here, you have to find the intersection. You have to find the intersection, which finally gives you that value. So we know that there's a formula for P of probability of A union B. Probability of A union B is the probability of A plus the probability of B minus the probability of A intersection B. So that means probability of A, this entire circle, plus the probability of B, so this entire circle, minus the probability of A intersection B. That means this part over here. That gives you P A union probability of A union B. So we just plug in our values here, so you get 0.85 is equal to 0.65 plus 0.45 minus PA intersection B. So after plugging all this in, you bring this over to the other side and you solve for P of A intersection B, and you should get the value of 0.25. Now let's do the B part. B part is find P of how what is this? A semicolon dash B semicolon. So this is a little bit harder over here. So this basically means that they're asking over here, you have to use a theorem that's given in the formula booklet that you have. The theorem is called, let me try to remember this. Yes, it's called the Bayes theorem. Bayes theorem. So in Bayes theorem, the rule is if you have any values like this, the rule is that they're basically asking, this value over here that you're trying to find is basically whatever I'm writing here. So A dash intersection with B dash over probability of B dash. That is how you find this value over here. That's what this dash implies. It's in the formula booklet, and this is the rule that you use over here. So we know we have these values over here, and basically probability of A dash intersection B dash, I just want to make this clear, is basically everything but this part over here. That means this part we do not include. P of A dash intersection with B dash is basically everything but this. That means everything on the outside. So all of this is what we include. This is what we want when they ask that. So that means that our value is 0.15. So P of A dash intersection B dash is 0.15. And probability of B dash, which is everything but B, right? Everything but B is this part over here and this. So if you solve for that, you should get that value as 0.55. So that is 0.55 down here, and that is equal to 3/11 once you simplify. I want you to keep it in this form because this is the form that I kept it in. And I'm pretty sure this is the form that the mark scheme kept it in, because you do not have a calculator and you can't find out what 3/11 is. So I keep it in this form. Now question 3. So again, I'm going to read it out and then pause the video and give it a go. So prove that bracket 3n plus 2 to the power of 2 minus 3n minus 2 to the power of 2 is a multiple of 12 for all n element of z plus. So go ahead, pause the video and give it a go. Alright, hopefully you've attempted it by now, and let's give it a go now. So the first thing that I would do here is obviously expand these two. So 3n plus 2 times 3n plus 2 is equal to 9n squared plus 6n 12n plus 4. That's it, expanded. And then 3n minus 2 to the power of 2 is 3n minus 2 twice. So that is also 9n squared, but now it is minus 12n plus 4. Yes, so if we do 9n squared plus 12n plus 4 minus the entire thing, 9n squared minus 12n plus 4 here, we get this cancels with this. This minus and minus make a positive, so you get 24n down here, because this adds with this once this becomes positive, right? And then minus, these two cancel out. So you should get 24n. And now they're asking, is it a multiple of 12? So you can automatically tell from here that 24 is obviously a multiple of 12. So you can say that since 24 is a multiple of 12, since 24 multiple of 12, every value is going to be a multiple of 12. So this is it is proved now, since you got 24n. Now let's move on to question number 4. So once again, I'm going to read it out, then pause the video and have a go at it. So the following diagram shows triangle ABC, where AB is equal to 4, BC is equal to 6, AC is equal to 5, and ABC is equal to 2 theta. So find the exact value of cos theta, giving your answer in the form of P root 2 over Q. And this is because it's a calculator question, non-calculator question. So again, pause the video and have a go. Okay, so hopefully you've gone through it now and you've had a go at this question. So now let's have a go at it together. So here, looking at this, since you're trying to find the exact value of cos theta, they've given you a hint over here by mentioning cosine theta. So when they mention cosine theta, that means that they're giving you clear indication to use something called the cosine rule. So the cosine rule, if I am not wrong, oh yes, it is also in the formula booklet. So I'm going to paste it on the board now. Yeah, so here's the cosine rule on the board for you to use for this question. I know I should have pasted it before, but once again, if you didn't get the answer, if you didn't get an answer, something like this, I want you to pause the video and try it again with this cosine rule, with this hint that I've given you. Okay, hopefully you've tried it now. So now let's get started. So right now they've given us 2 theta. So right now we do not change the value that they've given us. You can if you want to, but this is how I would do it. So cosine 2 theta is equal to, so we plug in our values. So B, we've taken as this. So this is B, so 4 squared, yes, plus C, this is our C, 6 squared, minus A squared, which is, this is our A, so 5 squared, over 2 times 4 times 6, yes? So now hopefully you should be able to expand this. So cosine 2 theta is equal to 16 plus 36, which is 52, minus 25, which is 27, and then 2 times 4 times 6 is 8 times 6 is 48, so this is 48, and this is equal to 9 over 16, once you simplify it down. So now you try to use something called a double angle identity. So you should have these memorized, or you can use the formula booklet. So the double angle identity I'm going to be using is cosine 2 theta is equal to 2 cosine square theta minus 1. This is what we're going to be using over here. So now we know what cosine 2 theta is, yes? So we attempt to plug it into this equation that we have over here. So cosine 2 theta is 9 over 16, right, plus 1 divided by 2 is equal to cosine squared theta. And then you square root this to get a value of so obviously you expand this, it becomes 9 over 16 plus 16 over 16, which becomes 25 over 16 over 2, yes, is equal to cosine square theta. And then you simplify it further because the 2 comes up, and eventually you get 75 over 96, yes. Cosine square theta is equal to 75 over 96. And then you put it in the form of, once you square root it. So, oh man, I'm running out of space here. Let's come up here. Up there. So cosine square theta is equal to 75 over 96. So cosine square theta is equal to 75 over 96. And then you square root, so cos theta is equal to square root of the entire thing. Right? And then you simplify this. Once you simplify this, you can take out, let's see, when you try to simplify this, it can simplify into 25 over 32. Square root of 25 over 32, right, is equal to, so this square root becomes 5 over root 32. Yeah, 5 over root 32. And then obviously you try to rationalize the denominator, and once you try to do that, you should get a final answer of 5 root 2 over 8. Sorry, I don't have enough space to rationalize the denominator, but that should be your final answer right there, 5 root 2 over 8. Let's move on. So now I'm going to try to save a little bit more space for further working out. Yes, so for a particular arithmetic sequence, U10 is equal to 16 and the sum of 25 terms is 100. So find the value of k such that u of k, so the term k, the number k, is equal to 0. So pause the video and give it a go. So you know that our formulas are u of n is equal to u1 plus n minus 1 times d, and for the sum is for our sum for u25 as sum from first term to 25th term, you can use the formula s of n is equal to n over 2 times u1 plus un. Yeah, that's the formula that you can use for the sum. There's another formula that you can use, but in this case this formula is applicable, so let's just use this because it's simpler. So first off, we plug in all our values. So 16 because it's u10, so that plus u1 plus, because it's 10 minus 1, it's 9d. And then for s of n, it's 100 is equal to 25 over 25 over 2 times sorry, we're not gonna get anywhere with this formula. Sorry, we have to use the other formula. I was a little bit mistaken over there. Sorry, you're gonna have to use another formula, not this one. Okay. Let's get rid of that. Yeah. So the formula that we have to use here instead is s of n is equal to n over 2 still times 2u1 plus n minus 1 times d. That is the formula we have to use here. So s of n, which is 100, is 25 over 2 times by 2u1 plus 24d, because you're plugging in the values that you have over here. And then from here we can start to solve. So here we created two linear equations that we have to solve. So 16 is equal to u1 plus 9d, and over here we can expand and simplify. So 100 is equal to 25 over 2 times 2u1, so this and this cancel, so it becomes 25u1 plus 25 times 24 over 2, which you can just like cancel out with the 24, so it's just 25 times 12, and then you can solve from there. So you have to solve it simultaneously. So once you expand this, you should get 25u1 plus 300d. So it's 16 is equal to u1 plus 9d. 100 is equal to 25u1 plus 300d. Yes. And then you have to simplify it accordingly. So the easiest thing that you can do is multiply this entire thing by 25, or you could simplify this bottom part over here, whichever way you want. So I'm going to simplify the bottom part. So if I divide the entire thing by 25, this entire equation by 25, by 5. Actually, I could do 25. Yeah, let's do 25. Let's do 25 instead. So if we divide by 25, we should get 4 over here, u1 plus 12d. Yeah, 12d. There we go. Divide the entire thing by 25, and that makes it way easier for us. So 16 plus u1, no, is equal to u1. What is wrong with my keypad today? Is equal to u1 plus 9d. 4 is equal to u1 plus 12d. Yes. So now let's try to solve. So if we minus this by doing simultaneous equations, we should get 12 is equal to, this cancels out to be 0 minus 3d. So d is equal to negative 4. u1 should be equal to, if you plug d back into the equation, you should get u1 as 52. 52 is our u1 value. And then once you attempt to solve for u of k, whatever k is equal to 0, you should get k is equal to 14. And when you plug that back into your equation for this over here, you put u of k over here, and then you plug in all your values that you know now, which is d and u1. And then you should get k is equal to 14. Now let's move on to question number 6. So once again, pause the video and give it a go. So in question 6 here, you have to first solve for 2x squared minus 15x plus 18, which is pretty simple because you just factorize. So if you do factorization, you should end up with 2x squared. You have to multiply to get 36 and add up to get multiply to get 36, add to get minus 15. So it should be minus 12 and minus 3, yeah. So minus 12x minus 3x plus 18 is less than 0. So then you factorize 2x squared, 2x on the outside, x minus 6, and then minus 3 over here. So x minus 6 here too, and then less than 0. So x minus 6, 2x minus 3. So x is equal to 6, and then x is equal to 3 over 2. So x has to be less than 6 but greater than 3 over 2 to satisfy this. 3 over 2. There we go. And now b. So the function f is defined by f of x is equal to square root of our function that we just solved, where x is element of every single real number and x has to be less than or equal to k. Find the greatest value of k for which f inverse exists. So the inverse function exists. So right now we found out like in our first part we found this out. So this will play a key part in finding out the answer to question B. So over here we know that x has to be less than or equal to k for f inverse to exist. So we know that due to our function that we found over here, k has to be equal to 3 over 2, because the greatest value that you can get for k right now is going to be 3 over 2, because it has to be greater than or equal to, less than or equal to. Yes, so for f inverse to exist, we require 2x squared minus 15x plus 18 has to be greater than or equal to 0. Because since it is now in a square root function over here, this, whatever 2x squared minus 15x plus 18 is, it has to be greater than or equal to 0. So for that to happen, f has to be 1 to 1. If you don't understand what 1 to 1 is, I will be linking a video where I reference and teach what a 1 to 1 function is, what is a function in general. So if you take any value above x, above 3 over 2, you will not get a 1 to 1 function. And if it is not a 1 to 1 function, it is not a function at all. It is not a function, it's a relation. And that means that f inverse will not exist, as f inverse of a function only exists for functions. I know I'm repeating functions again and again, but you have to understand here that if k is equal to 3 over 2, if it is not equal to 3 over 2, and you take any value of x, if x is greater than or equal to 3 over 2, you will get a graph that looks something like this, like that. That means that the horizontal line test that we do, it will not work, as there are multiple intersections and this function is not 1 to 1. So for k to be, for this function to have an inverse, for it to be a function, k has to be 3 over 2. That means that x has to be less than or equal to 3 over 2. Then and only then will it look something like this, where there's only one singular intersection. Sorry, that's a bad example. Something like that, yeah. Okay, then only will it look something like that, where there's only one singular intersection for all the horizontal line tests that you draw. So I hope that makes sense now. So x cannot be greater than or equal to 3 over 2, and k is equal to 3 over 2. And I told you this is referencing back to our original question that we had done for part A. Now let's move on to question number 7. So consider the function f of x is equal to secant x minus pi over 4 for 0 is greater than or equal to for x is greater than or equal to 0 but less than or equal to pi. So determine the range of f is the first question that we are given. So to find the range of f, we have to first find out the 0 of the function and pi over 2. So what we have to do to find the range of the function is plug in our domain. So the domain here is limited by 0 and pi over 2. So if we plug in 0, which is the least value, and pi over 2, which is our maximum value, we should get the same for the max and min for the range. So min and max. So if we plug this into our original equation, we should get our max and min values. So if we plug in secant of 0 minus pi over 4, secant of 0 minus pi over 4, f of 0, once you plug in f of 0, you should get secant. So secant, secant is 1 over cos. So our original value, if it was cos, would be 1 over root 2, but since it's secant and it's negative pi over 4, it should be root 2. Now if we plug in pi over 2, you should get secant of pi over 2 minus pi over 4, which in this case, this becomes pi over 2 minus pi over 4. If you do it correctly, you should get pi over 4. Pi over 2 minus pi over 4 is pi over 4. So initially what you're doing is secant of pi over 4, not negative pi over 4, pi over 4 only in this case. So once you do that, you should get the value of, a value of 1. Yes, pi over 4, yeah, 1. So those are our two values, and now we plug them in. So f of x, which we're detailing our range right now. So we plugged in 0 and we got root 2. So we know now that f of x will always be less than root 2, less than or equal to root 2. And since root 2 is greater than 1, we know that it has to be greater than or equal to 1 and less than or equal to root 2, because it has to be between these two. If we put root 2 over here, it would be f of x has to be less than or equal to root 2 and greater than or equal to 1. And that would not work because root 2 is greater than 1. So I hope that makes sense then. Now let's move on to question B. Question B. So the region bounded by the graph of y is equal to f of x, the x-axis and the lines x is equal to 0 and x is equal to pi over 2 is rotated 2 pi radians about the x-axis. Find the volume of revolution generated. See, this is a really annoying question to do. You just have to remember the formula. So the formula for this is, it's a volume of rotation over here. They're asking for the volume of revolution, the volume of rotation. So they've given you what it is limited by, 0 and pi over 2. Yes? They're limited by this, and you just need to remember the formula now. So the formula is whatever your values are. It's integral pi times integral whatever your upper bound is and your lower bound, and then whatever your function is squared. So secant squared x minus pi over 4 dx. So once you integrate this function, you know that secant squared, once integrated, it becomes tan. This is something that you need to remember. So secant squared integrated, secant x integrated, is tan. So pi times secant square, tan x minus pi over 4, and from pi over 2 to 0. So I've integrated this function over here. I've integrated it, and I'm now putting it. I still haven't plugged in the upper and lower bound yet, which I have to do now. Yes. So once I plug that in, I get pi times tan pi over 4, yeah, minus tan of minus pi over 4. So if you remember your unit circle, hopefully you do. If not, I want you to go and review your unit circle because it is key for this part over here. So we know that tan pi over 4 is root 2 over 2 divided by root 2 over 2 on the unit circle because tan is sine over cos. Is equal to tan. So tan sine of pi over 4 is root 2 over 2. Cos of pi over 4 is root 2 over 2 also. So this is equal to 1. So it is pi times 1 minus pi over 4 will be the same. It will just be negative. So negative 1. So essentially what you get here is negative and negative make positive. So you get 2 pi as your answer. What an amazing value to get after all that working out. Eh? Hopefully you've gotten that. Yes? So now let's move on to question number 8. Now once again I'm going to pause this video and allow you to read it and attempt it in your own time. So go ahead and read it. Okay, so let's get into question number 8. So question number 8 shows that the following diagram shows 2 points A and B such that OA is equal to A and OB is equal to B. So A and B at point P, this P lies on AB, so that AP is equal to lambda times AB. So where lambda is between 0 and 1. So show that OP is equal to 1 minus lambda times A plus lambda B. So I don't want you to look at this yet. Just think about O to P. This is what they're asking you to find. So they've said AP, A to P, is lambda AB. So OA plus AP will give me OP, which we are trying to find. So OA is easy enough, which is A, plus AP, which is lambda times AB. So AB is B minus A. So B minus A because for AB from A to B you have to take this route over here. So that's minus A plus B. So that's B minus A. And that is what you end up with. So then once you expand this you should get A plus plus lambda B minus lambda A. And then you can simplify this into A times 1 minus lambda plus lambda B, which is what they asked for over here. Now let's move on to part B. Now this is a 7 marker. So in the case that OP is perpendicular to AB, find the value of lambda. In the case that OP is perpendicular to AB, so O to P, they're asking for this line over here. In the case that OP is perpendicular, so this is OP, right? This is the line OP is perpendicular to AB, find the value of lambda. So in vectors, we know that any two lines that are perpendicular, their dot product will always be equal to 0. So OP dot product with AB will be equal to 0. So they've provided some information here. It is given that the modulus of A is equal to 1 and modulus of B is equal to 2. And A dot B is equal to 1/4. Yeah, so OP dotted with AB, that is equal to 0. And they provided some information. A dot B is equal to 1/4. So this vector dotted with this vector is equal to 1/4. So there are multiple methods that you can do this with, but I'm going to do it in a certain way, and hopefully you're able to understand that. So OP, we have OP over here, which is 1 minus lambda times, OP we got as 1 minus lambda A plus lambda B, right? This is our OP, dotted with AB, which is B minus A. we got b minus a because ab is minus a plus b. So that's b minus a is equal to 0. This is our dot product, which is equal to 0. So now you attempt to dot product these values. You dot the like terms together, and you should get these values over here, which is 1 second, I'm running out of space. Yeah, so hopefully this should be enough space now. So once you dot these two by doing scalar product, this is a scalar product. Come on. Okay, there we go. So a 1 minus alpha lambda, sorry, and lambda b, right? Scalar product with b minus a. So once you do this over here, you should get 1 minus lambda times a dot b plus lambda b dot b minus 1 minus lambda a dot a minus lambda b dot a is equal to 0. So, and then you attempt to substitute whatever values you get. So a dotted with a is equal to this, and b dotted with b is equal to modulus b. This is the rule. So now we have our values for this and this. We have our values for modulus a and modulus b. So we're going to use that up here, and we're going to use this too. So by substituting these values into our equation that we have over here, we should get 18 lambda minus 3 is equal to 0, and lambda is equal to 1 over 6. Now, I understand that I did not completely explain it, but I didn't have enough space, so I just simplified my working out once I plugged it in. And that is the complete overview of Section A of the November 2024 paper. Now, I hope that's clear.